perfect, the desire of Copernicus to get those perfect circular spheres back. The earth is the world of imperfection, of fallen bodies, of corruption and generation, time, of sin and death and sex and the mess of biology and disease. That is all fallen. But the heavens are supposed to be perfect, and they operate on a different set of laws than the earth. This is actually a very late holdover of what you get in Sumerian civilization as the separation of the world parents. You get this ancient myth where, starting with the Sumerians, the sky god On is cut and separated from the earth goddess Ki by Enlil. Then you get the same myth in Egypt when Shu comes in. Shu is the air god, and he slices the sky goddess apart from Geb, the earth god, and there you have the sky goddess is Nut, so that the cosmology is reversed. But that's the origins of this separation of the heavens from the earth, mythologically. But here in the Great Chain of Being, as we've sort of gotten it, is this idea of these two different sets of laws. Totally different. But now Tycho Brahe notices, well, there's a nova. There's not supposed to be new stars forming up there after all. This thing is a perfect eternal world, is it not? It's not the world of time. And so he begins to have doubts. So then he invites Kepler to come. He moves to Prague by this time. He's no longer in the Uraniborg. And he invites Kepler to come out. And Kepler is this brilliant astrologer whose mother was hunted as a witch and was nearly, would have been burned to death had he not had important connections. He was casting horoscopes for the nobility, and that probably saved his mother's life. And so he was this brilliant man who comes in, and the person in power is always the one holding all the stuff. And Tycho sort of just spoon feeds him these little bits of data. And particularly he wants him to solve the problem of Mars. Nobody can get the orbit of Mars right. So Kepler sets himself to work on this problem of constructing the orbit of Mars. And it's as a result of him thinking and meditating upon the orbit of Mars that he stumbles across the first two laws of planetary motion. The third law comes in later. The third law actually should have been known to astrologers. It's simply that the outer planets move slower than the ones that are closer to the sun. As any astrologer would have known that, of course. But the first law of planetary motion is that the planets do not move in perfect circles. They move in ellipses, right? And an ellipse is simply a squashed circle. But now the ellipse, if you sort of cut the ellipse, notice that it forms a parabola. And Galileo down in Italy, meanwhile, was working on the laws of falling bodies. And for him, the parabola was the archetype of falling bodies because if you shoot a cannon at a 45-degree angle, it'll trace out this parabolic arc, which is a perfect archetype of falling bodies. He's also rolling balls down inclined planes, and he's trying to get them to go further and further by greasing the planes and removing the friction and keeping them rolling, because he's inherited Bearden's impetus theory that a body should continue in motion forever unless it's slowed down by something external to that. So he's inherited that idea, and he begins to work out what's called the first law of physics, the law of falling bodies, namely that every body that's falling falls at the same constant rate of acceleration. Aristotle had said, in contrast, heavy bodies should fall faster than lighter ones, as is common sense, right? Well, the astronauts, when they went up on the moon, remember, demonstrated when they dropped a penny and a feather and they fell at exactly the same time. So Galileo was the first to begin to figure out that mass is not the same thing as weight. Mass is weight in the gravitational field, although he didn't have the idea of gravity just yet. But that's the first law of falling bodies worked out by Galileo in Italy, while Kepler, meanwhile, is working in Prague on the problem of the motion of Mars when he figures out these ellipses. The idea of these conic sections, Apollonius's conic sections had been translated recently, so they're probably playing around with these geometries as a result of these Greek texts. The second law of planetary motion is simply that planets sweep equal areas in equal times, which means that as the planet is moving in this tighter area of its orbit, it has to speed up in order to sweep that equal area in the same time that it was sweeping this area. So it sort of speeds up as it's going here, speeds up here, slows down, speeds up. So if it's doing that, that's a far cry from perfect motion. There's no uniform motion there at all. So the heavens slowly begin to look a lot like what's going on down here. Galileo starts looking through his telescope. He notices craters on the moon. He notices that Venus has phases like the moon. He notices that there are moons whirling around Jupiter. So they begin to realize that the laws of the heavens are the same laws operative down here on Earth. So this idea of two sets of laws began to be done away with. Now Kepler was sort of, he was the one who sort of killed the anima mundi, just put it to rest. He said, And the third law, remember, is simply that the planets that are farther out move slower. And with respect to that motion of those planets, he began to realize, wait a minute, what if we do away with this idea of an anima mundi, a soul moving these planets, and we begin to say, instead of a soul, what if we say that from the sun there's a force emanating out from that sun that gets weaker the further the planets are out from the sun? That would account for why these planets are moving slower as they get further out from the sun. He didn't know that the force was gravity, but what he thought it might be was magnetism, because Gilbert had just published his work on magnetism. So he thinks magnetism is this force radiating out from the sun, pushing these little planets along. So now we begin to get the formation of the cosmos as we know it today. And Kepler said, you know, if you think of what I'm doing here, what I'm doing is, don't think of soul, think of force, and think of a mechanical clock. The way in which the solar system moves is directly analogous to a mechanical clock, and that's the way I want to convey this. And so he sort of had his feet in both worlds, and he was truly a revolutionary. And he was writing these letters to Galileo. Galileo was very rude to him, wanted nothing to do with him. He did have the use of a telescope briefly, but mostly he worked this out with naked, raw eye observation and persistence. And so that's what Kepler did. Now with respect to Newton, Newton says, if I have seen as far as I have, it's just because I've stood on the shoulders of giants. And these were the giants whose shoulders he was standing on. That's to be compared, by the way, with the acceptance speech of Murray Gell-Mann, the guy who came up with the quark hypothesis, where he said, if I have seen farther than anyone as I have, it's because I'm surrounded by dwarves. So he wasn't very nice about So Newton just comes in and, standing on the shoulders of these giants, puts everything together. What's going on in Italy? The laws of terrestrial motion. Galileo's working those out. What's going on with respect to Kepler and Bray? The laws of planetary motion are being worked out. If we fuse these two sets of laws together on the basis of universal gravitation, then we have the idea of this. The entire universe is held together by one law, the law of universal gravitation. The same force that makes the apple fall from the tree must make the moon fall perpetually around the Earth, and the planets fall perpetually around the sun. They're simply to be regarded as falling objects that somehow never hit their targets. Why don't they hit their targets? That became a problem for him, and a problem that lasted and is still going on. He thought, well, if the planets never hit their targets, it's because God has to periodically intervene to reset the planetary orbit so that the planets don't go crashing into the sun. So he still has to have recourse to God, but now God is in the back seat, and he's sort of the driver turning back to ask a question now, right? So God is being slowly marginalized, pushed into the background as a result of this. And so it was Newton who remarried the world parents. He remarried Uranus and Gaia through this theory of universal gravitation, and then the three laws of motion. He picks up the law of inertia from Descartes, probably, and sets everything going. And so then Descartes now, just to sort of finish off this aspect of all this, Descartes rejected Newton's theory, and in fact, most everybody on the continent rejected it because it still sounded like the anima mundi. It still sounded too much like, what is this occult force that's acting mysteriously upon objects from a distance? How do we visualize that? What is it? It sounds a lot like an occult property. And it was known that Newton was interested in alchemy. He was still into the occult. He sort of kept it in the closet, but he was interested in these things. So what happened then was Descartes comes in and he says, I don't believe this. I don't believe this theory at all. And so he picked up this theory of matter as being made up of these atoms. The atomic hypothesis was coming in now. So astrology was going out at the macrocosm, and the atomic theory was coming in because Lucretius's text, De Rerum Natura, which is all about the Greek atomist theory, had been translated, and it passed around through the French and the British, and they all became fascinated with this corpuscular idea. Matter is made up of these tiny little particles in motion. That's completely at odds with the idea of the four elements. You can't reconcile those two at all. Either things are made up out of four elements in varying juxtapositions, or they're ultimately made up out of these tiny little particles moving around in motion. And it began to be thought, as a result of this shift from the ontology of elements to the ontology of atoms, alchemy fell out. Because alchemy depended entirely upon the four elements. The metals were ripening. They were